Hi, welcome back. This is Professor Ridge. Today's lesson, section 5.4, factoring trinomials. So there's two types that we're going to cover. The leading coefficient being 1. And then the leading coefficient being something different than 1. Okay, so we'll first start out with this one. Alright, so first some of my own terminology. So a factor pair, again this is my terminology, a factor pair of 24 is a pair of whole numbers whose product's 24. So if I ask you to find all the factor pairs of 24, so what two numbers that multiply to 24? So let's see, there's, so this way I do it. And I usually have you start with 1. 1 times 24, 2 times 12, 3 times 8, 4 times 6, 4 times 6, and then 5 doesn't work, 6 is there, so I know I'm done. Okay, so I'd like you to kind of think of this system. Here we'll do more than one. So how about, let's say if I wanted to do 60. So again, you start with 1, and again, when I teach my students, if you struggle with knowing what are factors of a number, you can use a calculator. There's nothing wrong with that. It's nice if you can do it without a calculator, but you know, if you struggle, pick up a calculator. 60 divided by 1 is 60. 60 divided by 2, you just punch it in your calculator, 30, or hopefully you know it without a calculator. But when you practice a lot, you'll start seeing you'll use the calculator less, so I do like to kind of teach you with the calculator. 60 divided by 3 is 20, 60 divided by 4 is 15, 60 divided by 5 is 12, 60 divided by 6 is 10, 7 you wouldn't get a whole number. 60 divided by 8 can't do. 60 divided by 9, and then 10 is there, so I know I'm done. Okay, so these are all of them. These are all the factor pairs. They want all. Let's do one more. How about 84? So 1 times 84, 2 times 42, 3 times 28, 4 times 21, 5 doesn't work, 6 would be 14, 7 doesn't work, 8 doesn't work, 9 doesn't work. Now, instead of going to the, okay, so here's a shortcut too. If you got out your calculator and hit square root of 84, and punch that in your calculator, so I'll do that right now. 84 square root is 9.6, so I can stop at 9. Basically, you just chop off the decimal point. I can stop at 9. So nothing bigger than 9 will work. If it did, it's already on the list. So like 14 works, but I already did it with 6. So if you had one that's bigger than 9, you have to have one that's less than 9. So like 14 and 6, right? One's bigger than 9, one's smaller than 9. So there won't be any more. You can kind of stop there. All right. So that's how you find the factor pairs, and that's a very important technique for factoring trinomials. So let me show you how I do it. Okay, so the first thing I do is I look at the C term, the last term. Factors of 24, this sign in front of C, negative 24, that tells me I'm going to take a factor pair of 24 that subtracts to whatever this B term is, 5. So I want to find a factor pair, and normally I just write factors that subtract to 5. Now notice I don't have any signs in here. The minus 24 tells me that I'm going to subtract factors of 24 that get me 5. So if you look at A above, those are all the possible factor pairs. Which ones subtract to 5? So if you did 24 minus 1, that's 23. That wouldn't work. 12 minus, you just do the bigger one minus smaller one. That's 10. That doesn't work. 8 minus 3 equals 5. That's the one I want. So what you do, you make your two sets of parentheses, and remember we're doing the reverse FOIL basically is what we're doing. So to get the x squared for the first term, that's x times x. To get the 24, I need these two numbers to multiply 24, so that's why I think through all the pairs there. And so we decided it was 8 and 3, or 3 and 8. Doesn't matter which order you put it. What does matter now is to get that middle term when we FOIL. See, look, you're going to get, well, anyway, let me just tell you the way I do it. So now my next step is I put in the sign. This goes to the bigger factor in the factor pair. So this negative goes to the bigger number, which is 8, which goes there, because this is the bigger number. Bigger factor gets the middle sign. Okay? And then my next step to get a negative 24 when you're doing a product, 8 and 3 have to be opposite signs. So since 8's negative, 3 has to be positive. Okay, and that's all there is to it. Okay, so to get a negative 24, eight and 3 have to have opposite signs. As each other. So if the bigger one gets the middle sign, and the bigger one's 8, it gets a negative. And then the 24, to get negative 24, I need a negative 8 and a positive 3, because they have to be opposite signs of each other. All right, let's try another one. If I did x squared plus 17x minus 60, so again, I'm going to look for factor pair of 60 that subtracts to 17. So factors of 60, so just because I'm getting lazy, I won't write factor pair. Factors of 60 that subtract to 17. So I'm going to put in my parentheses, x, x. So you go through the b up there, factors of 60 that subtract to 17, which would be 20 minus 3 equals 17, so that's the one I want. 20 times 3 equals 60. See, so it works for both conditions. Factors of 60 that subtract to 17. So it's 20 and 3, and again, it doesn't matter where you put the bigger one. But what matters is the bigger factor gets this middle sign, so this is the bigger one. It gets the middle sign, so that's a plus. And then to get a negative 60, I need one positive, one negative. So if the bigger one's positive, the other one has to be negative. And look, if you check it, you're going to FOIL x times x, there's your x squared, x times negative 3x, 20 times x. So see, that's where you get the 20 and the 3, and then negative 60. And you combine like terms, the negative 3 plus 20 is positive 17x. And you see that all three terms match. So x plus 20 times x minus 3 would be factoring the original trinomial. All right, let's do one more on this page. x squared plus 44x plus 84. And again, we're going to look for factors of 84 that add to 44. Factors, and normally I don't write this down either, just showing you my thought process. Factors of 84 that add, so it's that last sign, the sign of C tells you if you add or subtract. So in problem A and B, you see that it was negative, so I subtracted the factors. Here, this is positive 84, so I'm going to add. This tells me add or subtract. So factors of 84 that add to 44. Okay, so I go through all the factors of 84. Which ones add to 84? So if you look above at C, 1 plus 84, that's 85, no good. 2 plus 42, that's 44. So it's 2 times 42, that's 84. 2 plus 42 is 44. So that's the one I want. X times x is the x squared. 2 and 42 get the 84. They add to 44. Now I put in my signs. Now notice, I don't think about signs till very last. This is a little different than the way the book presents it. I find this way people make less mistakes. So, you know, you could do it this way, or you could do it the book way, or if you're good at it already, you can stick with your method. Okay, so the bigger one gets the middle sign, and then to get a positive 84, the way you get a positive when you're multiplying is both signs have to be the same. They're both negative or they're both positive. So if the bigger one's positive and the signs have to be the same, that means they're both positive. Alright, so that's how you factor a trinomial when the leading coefficient is 1. Now let's change it to having a number in front, like 3x squared or something like that. Alright, next page. Okay, so we're going to factor trinomial when the first term, a term, is not a 1. The leading coefficient's not a 1. And again, I'm going to do totally different than the book on this one. Not just mildly different, but different. And we call this the ridge method because I came up with it a long time ago, when I was in college, probably in the 90s, or 80s actually. Anyway, so factoring trinomial using the ridge method, okay? Professor Ridge, that's me. All right, here we go. All right, so the first step is just like before, except I'm going to make this modification. I'm going to take factors of a times c that add or subtract to whatever that first number is. So you're going to find factors, factor pair of a times c that add, if that's plus, or subtract to b. Okay, so the same thing. Alright, so we'll put a little note here. How do we know if we add or subtract? So it's the last sign, the sign of C. Tells you to add, again if it's plus, or subtract if it's minus. It tells you add or subtract the factors to get B. Okay. Alright, so that's our first step. And let's say M and N are the ones that work. Are the numbers that work for both conditions. What do I mean by that? I mean specifically that m times n is a factor pair of AC, and m plus or minus n is equal to, this should be A times C, right? Just trying to save room there. M plus or minus n is B. Now, it can't be plus or minus. It's plus if C is plus, and it's minus if C is minus, that last term. Okay, so let's say we find those. And the way we're going to write this, okay, so I set up a problem like this. Notice I have A 3 times. And I'm going to do some numbers in a second, but I'm just going to write it up this way, and we'll follow this procedure. So step 1, once you find step 1, you're going to put in that m and n that multiply to AC, not to C, to AC, and add or subtract to B. Okay, so that's your first step. Now your second step is you're going to put in signs. Okay, so our first step is to put in signs. So the step 2, put in signs for m and n. The first step is you're going to look at the sign of B, the middle sign, right? The middle sign. The larger of the factors, m and n, gets the same sign as B. So if m's the bigger number, whatever B is, m gets that sign. If n's the bigger one, then that gets the sign of B, the middle term, okay? So let's say if m was the bigger one, you're going to put in whatever sign B has. And then, so now you're going to look at okay, so look at sign C. If C is positive, C is a positive number, then both m and n have the same sign as B. So if B is positive, m and n are both positive, provided C is positive, right? If C is negative, then C is negative, then m and n have opposite signs as each other, all right? So then you put in the signs. So first you look at the bigger one. Okay, that's step 2, actually. Okay. So once you find m and n, you put them in. And then step 2, you put in the signs. And then the final step, this is you reduce that fraction. So this is the answer. From 2 is the answer. Once you reduce. Expression. So how do you reduce this expression? It's kind of like we're a little bit ahead, kind of mixing different techniques, but basically you got to remember to reduce. So this is what we're going to cover in the next chapter. To reduce, you're going to factor each parenthesis separately. Okay. And then cancel. With the numbers that you factor out, you cancel the number on the bottom. This will make more sense once I show you with numbers that are factored out. Cancel the A on the bottom. That if you did, that's the A will always cancel. Okay, in the denominator, I should say. All right, so now you just got to reduce. Okay, that's it. So basically that's how you do it. So let me squeeze a problem over here on the side. So let's say I have, let me look at the other page. So if I want factors, let's try something like this. 4x squared plus 25 or minus 25x plus, or let's do minus 3, or 21 I should say. So now we're going to do factors of 84 that subtract the 25. So 4 times 21 equals 84. So I want factors of 84 that subtract to 25. Alright, so we're going to go through our factor pairs, and if you look on the last page on C, 3 and 28 work. And 28 times 3 equals 84. So that meets both conditions. So again, the way I'm going to write this is I'm going to write 4x over 4. This is the ridge method again. This is what's different. You won't see this too many places. I've taught a lot of teachers how to do this, so you might have seen it before. Okay, so 4 times 4 is 16. 4x times 4x, 16x squared. That's why I got to divide it by the 4 to fix it. All right. Now we got 28 and 3, or 3 and 28. Doesn't matter which way you write them. Now I do the same thought process for the sign. The bigger number, 28, gets the sign of B, which is negative. And then to get a negative 21 as a product, these signs have to be opposites. So the 3 will be a plus. Alright, and now that's the correct answer once I reduce it. So the way I reduce it is you look at each parenthesis separately. Does anything come out of 4x plus 3? And the answer is no, so you leave it alone. Does anything come out of the 4x minus 28 that divides out of it? And the answer is yes, 4 does. So you factor out the 4, and you get x minus 7. Because you divide both the 4x and the 28 by 7. And now I can cancel with that number that I pulled out of the second parenthesis. I can cancel the 4 in the bottom. And my final answer would be 4x plus 3, x minus 7. And I'm done. So I like this method a lot better than the guess and check method, the reverse FOIL, whatever you want to call it. The book shows you an AC method. It's kind of similar to this, but then you use factor by grouping. But this is the way I do it. It's called the ridge method after me. So I encourage you to try this. Let's try one more. Okay, so let's try this one. 6x squared plus 31x plus 40. So again, I'm going to go 6 times 40. That's 240. And then I'm going to do the factor pairs of that. 1 and 240. 2 and 120. 3 and 80. 4 and 60. And remember, I'm looking for factor pairs. That add to 31. Now see, this is 64. And with a little practice too, you know, I can probably go down the list a little further because they're going to be they're going to be a lot closer together. But just to show you, so I'm going to get out my calculator. So if you don't know 5 times what's 240, just go 240 divided by 5. This is a great technique when it's not the first one or two that pops in your head. 6 times 40. 7 doesn't work. 8 times 8 times 30. So we're 38. We're getting closer. 9. I don't think 9 works. 240 divided by 9. Nope. 10 and 24. That's 34. Getting closer. 11 doesn't work. 12 and 20. 32. Closer. 13 doesn't work. 14 doesn't work. 15 times 16. Let me double check that. 240 divided by 15 is 16. And there it is. And that's the last possible one. But I found it. You see, that didn't take a long time. 240 is a relatively big number, but, you know, no big deal, especially with that technique. Okay. And then I'm going to take factors of, oops, not 240, that's going to be 6. So let's see, 15 and 16. And then my signs, bigger one gets plus, because the middle sign is plus. And then to get a positive 40, these two things have to be the same sign. Now I know 15 times 16 is not 40. Remember, it's too big. That's why I got to divide by the 6 on the bottom. So I'm going to factor the first parenthesis, and what divides out of 6 and 15? Well, that's 3. So you get 2x plus 5. What comes out of the second parenthesis? You should say 2. So 6 divided by 2 is 3. Remember, it has to divide in both of them. So 16 divided by 2 is 8. And you're looking at both parentheses separately. And then I can bring that 2 out to the front with the 3. 2 times the 3 is the 6. And that cancels the 6 on the bottom. And so my final answer are those two parentheses. 2x plus 5, 3x plus 8. Sorry that I squeezed it all in there, but there you go. Alright, so let's try a couple more just to make sure you got this from the exercise set. So go to the next page. Okay, so if we look at 56, you got 8x squared minus 16 minus 28x. Okay, we want to put it in descending order. Okay, I'm going to look for factors of 8 times 16, which is 8 times 16 is 128. That subtract to 28. I know some of you are going to tell me about, oh, I have the diamond method. That's fine. You can use that, or the X method, whatever you call it. All right, so let's go through my list of 28. 128. 128. 2 and 64. 3, and I believe that doesn't work. Yeah, that doesn't work. 4 and 32. 5. Oh, that one works. That makes 28. So we stop there. Oh, no. Let's look at this. My first step should be first factor out GCF. So now let's pretend I didn't notice that. Okay, so what divides out of all these? 4. So the idea would have been I would go 4 times 2x squared minus 7x minus 8. No, minus 4. And then I'm going to do the factors of 4 times 2, which is 8, let's subtract to 7. Okay, so factors of 8 that subtract to 7 would be 8 and 1, so I don't need to write anything down on that one. First one popped in my head. The bigger one gets the negative. The signs are opposite. And then I got to reduce. So I got the 4 that I factored out to begin with. A 2 comes out of the first parenthesis. Nothing comes out of the second parenthesis. And now the number that I just pulled out, the 2, cancels the 2. So I get 4x minus 4, 2x plus 1. And that's my final answer. Now, let's pretend, this is another reason I like teaching the ridge method. Let's pretend I forgot to do it like I actually did, but let's say I didn't catch it when I did. So I'm going to let's just go on my business, my merry way like I was doing. 8x, so whatever that first term is, I write it 3 times. 8x, 8x, 8. Now factors of 128 that subtract to 28 was 4 and 32. The bigger one of 4 and 32 is 32, gets the middle sign, so that's negative. And then to get a negative for the product, these two have to be opposites of each other. Now again, this is why I want to stress that you're going to look at the parentheses. Don't worry about the 8 on the bottom yet. Just factor each parenthesis separately and just ignore everything else. So the first parenthesis, I can divide a 4 out of both of those numbers. So that's 2x plus 1. The second parenthesis, I can take an 8 out. And that leaves me 1x minus 4. And then with those numbers on the outside of the parenthesis, I can cancel the 8. I could take a 4, leaves 2, take a 2, or I just take the whole 8 at the same time. And then that 4 that came out, that's left over on top, that's the original 4 that I should have caught to begin with. But if I didn't, I catch it at this stage, provided I think of those parentheses separately and factor everything out. The drawback of not doing the GCF first is, notice the numbers are a lot bigger. I had to do 128, where here, if I caught it first, I only had to do factors of 8. So you want to look for GCS first, if you can. But if you don't, it's not a big deal. You can still catch it later. But you've got to remember, you always got to factor completely. So don't just try to get the 8 out. Get everything out that can come out. But the 8 will cancel. And if there's extra left over, that just means you should have factored a GCF to begin with, like I did the first time. Alright, so that concludes our lesson for sections 5.4. Go to my math lab and complete the exercises there, and I'll see you next time.